Hello and welcome to this presentation of the STM32H5 comparator. It covers the main features of the ultra-low power comparator and gives some application examples. The comparator inside STM32H503 microcontrollers provides a binary output, which indicates if the analog voltage on the plus input is larger than the voltage on the negative input. It allows the microcontroller to react when the analog signal crosses a predefined threshold. The comparator continuously monitors voltage in contrast to an analog-to-digital converter which operates in sampled mode. The comparator can be used to wake up devices from sleep and stop modes. Note, this is not possible when the internal reference voltage is switched off. Applications can benefit from the flexible configuration of comparator properties, which can be logged for safety reasons. Another safety feature of comparator is its ability to generate a break signal for timers, allowing to safely stop the generation of PWM driving signals. The analog properties of the comparator include hysteresis, or a trade-off between speed and power consumptions, are configurable. It offers flexible interconnections of inputs and outputs, allowing a threshold selection of several external and internal inputs, such as DAC outputs or internal reference voltage outputs. The comparator output can be connected to I/Os using the alternate function channels or internally redirected to a variety of timer inputs, such as enabling the break event for fast PWM shutdown. The user can create cycle-by-cycle current control or input captures for timing measurements. This slide shows the general block diagram of the comparator integrated in the device. Positive and negative inputs of the comparators are selectable through multiplexers. The output of the comparator can be inverted before being ANDed together with the input selected for blanking. The resulting signal can be steered to general-purpose input-output pads, EXTI module, timers, and maskable interrupt line. The comparator power consumption can be adjusted to have the optimum trade-off between the speed and energy efficiency for a given application. There are 3 modes available: high speed, medium speed, and ultra-low power. The high-speed mode is preferred for power conversion applications, for example, a motor control design, while ultra-low power mode is the right choice for battery-powered applications where reaction times are not critical, for example, in PIR sensor monitoring. The comparator can stay active even if the rest of the system is suspended and the clock is switched off. The comparator can trigger an interrupt on the raising, falling, or both edges of the comparator output through the EXTI line, which can be used as a wake-up event to exit sleep and stop modes. The output can also be directly connected to the CPU's nested vectored interrupt controller, or NVIC. The on-chip comparator remains active in the following modes: run, sleep, and stop modes. In standby mode, it's powered down and must be reinitialized for use if returning to one of the higher-powered modes. The on-chip comparator configuration capability allows the user to select the best performance point for the targeted application. It replaces the external standalone comparator, thereby reducing the bill of materials. Comparator output values can generate break input signals for the timers on input pins using GPIO alternate function selections incorporating the I/O open drain connection. The purpose of the break function is to protect power switches driven by PWM signals generated by timers. The 2 break inputs are usually connected to fault outputs of power stages and 3-phase inverters. When activated, the break circuitry shuts down the PWM outputs and forces them to a predefined safe state. Please see the timer training slides for more details. The comparator can be used in the cycle-by-cycle regulation loop for monitoring the peak value of the current flowing into the load. The purpose of the blanking function is to prevent incorrect current regulation tripping due to short-duration current spikes at the beginning of the PWM period. Short current spikes caused by activating the power switches can produce false pulses on the comparator output, marked by the blue color on the diagram. These pulses need to be masked by a blanking window to avoid false fault detection. The blanking window waveform can be generated by one of the timer output channels. This table is showing comparator flexible I/O assignment. For more information, please refer to project datasheet. This is a list of peripherals related to the comparators. Please refer to these peripheral trainings for more information if needed. Thank you for attending this presentation.